Welcome to the calculation part of Graham's law of diffusion. Now, example 1 says that 200 cm cube of hydrogen diffused through a porous spot in 40 seconds. How long will it take 300 cm cube of fluorine to diffuse through the same pot? Now, when it comes to questions like this, don't get confused. I'm going to show you the simple way that you are going to solve these questions, the way you are going to arrange it without getting confused at all. Now, when it comes to Graham's law of diffusion, we used to have two gases. Now, to pick out those gases without confusion, just distinguish the two gases from each other. Now, we're having two gases here, which are hydrogen and what? Chlorine. And what is the first gas? The first gas here is what? Hydrogen. And the second gas is what? Chlorine. Now, everything coming first will be attributed to hydrogen. And everything coming next will be what? Attributed to what? To chlorine. Now, we're having two gases, which are hydrogen, which is diatomic in nature, diatomic H2, and we have what? Chlorine, which is also diatomic in nature. Now, for hydrogen here, we can see that from the question, we have volume, we have time. So we have volume and we have what? And we have a time. So it means we are using the formula that relates volume, time, and molecular mass. Now, how do we get the molecular mass? We can calculate the molecular mass from the hydrogen molecule we are having here and the chlorine molecule we are having here. We know that hydrogen has a mass of 1. And since we have 2 atoms of hydrogen here, that will be what? 1 times 2. So that will serve as the molecular mass for hydrogen. And chlorine is what? 35.5. And how many atoms of chlorine do we have here? We have 2. So it means that we are multiplying 35.5 times 2. So that will account for the molecular mass of what? Of chlorine. So from the question, we have volume, we have time, we have what? Molecular mass. And don't forget, everything coming first belongs to hydrogen. And everything coming next belongs to what? Chlorine. So we can say that our V1, T1, and M1 all belongs to hydrogen. V2, T2, M2 all belong to chlorine. So what comes first belongs to hydrogen. What follows belongs to chlorine. Now what comes first now? 200 cm cube of hydrogen. So we're having 200 cm cube. 200 cm cube of hydrogen diffused diffused through a porous spot in 40 seconds. So what happened? Hydrogen diffused through a porous spot in what? 40 seconds. So this 40 seconds here also belongs to what? Hydrogen. So we have 40 seconds also for what? For hydrogen. Hydrogen diffused through a porous spot in what? 40 seconds. This porous spot here is a term for, like, let me say a container that is having like holes. That is having like holes, like tiny holes that gases can easily pass through. So Hydrogen diffused through that porous spot in 40 seconds. So you have the time here. The time here. Now, what is the molecular mass for hydrogen? Like I said earlier, hydrogen has a mass of what? Of 1. But hydrogen is diatomic in nature, meaning it exists to be having 2 atoms. So the 2 atoms are bonded together by covalent bond. So you have H2. So you have 2 atoms of hydrogen, and that will be 1 times the 2. So finally we get what? 2 gram per mole. Or you can say 2 gram. You say correct. So this is the unit for molar mass. Gram per mole is unit for molar mass. So if we use molecular mass, you can say gram, you are say correct. If you say molecular mass, you can still use gram, as the case may be. Now that's for hydrogen. That is for hydrogen. So for here now, it depends on how you want to put your question. You can decide to put gram per mole. You can decide to put gram. So that's for hydrogen. Full stop. How long will it take 300 cm cube of what? Chlorine. 300 cm cube of chlorine, of fluorine. So we have what? 300 cm cube attributed for chlorine. So we have what? 300 cm cube given to what? To chlorine. So we have 300 cm cube given to chlorine, and we have what? 200 cm cube. 200 cm cube given to what? Hydrogen. 200 cm cube of hydrogen. And we have what? 300 cm cube of chlorine. Now what's the next thing there? So what's the next thing there? How long will it take 300 cm cube of fluorine? So what happened here? How long means what? Time. How long? Time. How long? Time. So how long will it take 300 cm cube of fluorine? So there. Okay, let me finish it. How long will it take 300 cm cube of fluorine to diffuse through the same pot? How long will it take chlorine to diffuse through that same pot? How long? How long? So there, the time is in question. Question mark. So that is what the question is. Now, molecular mass now. The molecular mass for chlorine is what? 35.5. 35.5. And we have 2 atoms of fluorine. That will be what? Times 2. We multiply further, we get what? 71 gram per mole. 71 gram per mole. So this is our values. So the question is that how long will it take 300 cm cube of fluorine to diffuse through the same pot? How long? Meaning the time taken. So we are giving volume, we are giving time, we are giving molar mass. Now the formula we are going to make use of is what? The formula relating volume, the formula relating time, and the formula relating molecular mass, which is what? V1 T2 over V2 T1 equals to square root of what? M2 over square root of what? M1. Now, I'm making this video as part 2. As part 2, I've already explained how I derived this formula in my part 1 video. So I'm making this video to be part 2. Now, from here now, we are not giving our T2. So to make our work much more easier, we can make this T2 to be what? We can make this T2 to be subject of the formula. And how do we go about that? Just cross multiply. Cross multiply. So we have what? T2 T1 square root of M1 equals to what? V2 T1 square root of what? M2. T2 V1, T2 V1, T2 V1, T2 V1 multiplied by M1 equals to V2 T1 multiplied by what? Square root of M2, square root of M1, square root of M2. Now, so divided by the coefficient of T2, V1 square root of M1 over V1 square root of M1. So this cancel this. So finally we have T2 equals to V2 T1 square root of M2 over V1 square root of M1. So this is the formula we are making use of to solve our question. So from there now, we can now have our T2 to be equal, so our V2 is what? 300 cm cube. So we have what? 300 multiplied by our T1 is what? 40 seconds. So we have our T1 to be what? 40. So we have 40 multiplied by our what? Our M1 is what? Our M1 equals to what? 2. Our M1 is 2. So we have what? Square root of what? Of 2 over. Now our V1 is what? Our V1 is 200. 200 multiplied by our M1 is what? So this is our M2. Our M2 is this is the M2 here, no M1. M2 here 71. So we have 71. So our M1 here is what? 2. Square root of 2. From here now, let's now multiply our T2 equals to now 300 multiplied by 40 multiplied by square root of 71. We get 101,103.8 over 200 times square root of 2, get 282.84. 282.84. So our T2 now equals to, when we divide further, we get our 357.5. We have 357.5 seconds. So this is our final answer. This is our final answer. So this is the answer for number one. Answer for number 1. So I first of all make this T2 the subject of the formula by first of all cross multiplying. So when I cross multiply, I have my T2 V1 multiplied by what? Square root of M1 equals to V2 T1 multiplied by square root of M2. So, yeah, so I have this and I have this. So to make this T2 to be alone, I have to take off this 2 that is disturbing it. I have to remove this 2 that is disturbing it. If I want to make this one the subject of the formula, I will have to remove this one and this one also. But I'm making this one the what? The subject of the formula. So I have to divide by these 2. So I divide it, so I get this. So here now, and I apply, I impute the value, so I get my final answer. So this is for question number 1. For question number 2 now, if you can do well to ask any question in the comment section for any unclear parts. and I'll try my possible best to give response to every question asked. So you are free to ask any question in the comment section so I can provide the answer to every question asked. Now, example 2 now. Under the same conditions of temperature and pressure, hydrogen diffuses times as fast as a gas Y. Calculate the relative molecular mass of X. The relative molecular mass, which is RMM of hydrogen. RMM means relative molecular mass. So the RMM, which is the relative molecular mass of hydrogen, equals to what? 2. Equals to what? 2. Equals to what? 2. So the same way also, we are dealing with what? Two gases, which are hydrogen and gas X. And notice, hydrogen came first before gas X. So we have what? Hydrogen, which is a diatomic H2, and we have our what? Our gas X. Our gas X. Now notice in the question, are we giving time? Are we giving volume? Are we giving relative molecular mass? Now we can see that from the question here, we are not giving time, we are not giving volume. What's the question? Under the same conditions of temperature and pressure, hydrogen diffuse 6 times as fast as a gas X. So what happened? We are giving rate. We are giving what? We are giving rate. Yeah. We are giving rate and we are giving what? The relative molecular mass. So the formula we are making use of here is what? So let's our R1, the marker is come back to life. Marker come back to life. So we have our R1 to be equal to, now be careful, under the same condition of temperature and pressure, hydrogen diffuse 6 times. 6 times as what? As gas, as fast as gas X. So the rate of diffusion of hydrogen is what? 6 times. Is what? 6. And the molecular mass is what? Is 2. Is 2. We have 2 here. That is the M1. Now, for the gas X now, we have our R2 to be equal to what? 1. Because they said that hydrogen diffuse 6 times as gas X. So if hydrogen diffuse 6 times, so gas X, we have its rate to be 1. So we have 1 time. So let's say here we have 6. Let's say here we have what? We have 1. So our M2 is what we are looking for. Because the question says that what? What's the question? Calculate the relative molecular mass of what? Of gas X of X. So what do we do here? We make use of the first formula that I derived. You can watch that out in the part 1 video. So we have our R1 over R2 equals to square root of our M2 over square root of what? Our M1. So what's in question here? So we are seeing that M2 is having question mark. So what do? We make M2 the what? The subject of the formula by cross multiplying. So we have our square root of M2 multiplied by R2 equals to square root of our M1 multiplied by what? Our R1. So what do? Divide both sides by what? By R2 to make this M2 to stand alone. So that be what? Over R2. Marker come alive. So R2 over R2. So R2 cancel R2. So we have our square root of our M2 to be now equals to what? Square root of M1 multiplied by R1 all over R2. So this is what we are making use of. So from here now, we can now furthermore to now input our value. So we can now say that let me just quickly put another ink. Do I have ink here? I don't think I have ink here. Anyways, let me just manage it. So our M2 square root of the M2 equals to our M1 is what? Our M1 is what? Our M1 is what? 2. Our M1 is 2. So we have square root of 2 multiplied by our R1 is what? Our R1 is 6 over our R2 is what? 1. Our M1 is what? 2. That's the square root of M1. We have 2. Our multiplied by our R1 is what? 6. And our R2 is what? 1. So square root of M2 equals now square root of 2 multiplied by 6. So we get 8.485. 8.485. So we have 8.485. 8.485. Now from here now we can square both sides just to eliminate this square root. Square both sides to eliminate this square root. So that will be what? We already know that this M2 raised to power half is what? The square root. The square root. I want to show you how we used to eliminate this square root by squaring both sides. Don't get confused. I want to show you how to eliminate square root by squaring both sides. Now, anything having square root is raised to half. What do I say? Anything having square root is what? Raised to power. Is raised to power of what? Power of half. So we can rewrite this one as what? M2 is what? Raised to power of half. So equals to 8.485. Now squaring both sides now. So here will be what? Raised to power 2 again. And here will be what? Raised to power 2 again. So here will be what? Multiplied by 2. And here will be what? Also be what? Here will be raised to power 2 also. There's half here before. So another raised to power 2 again. So this one, so these two multiply this half here. So here also raised to power what? Raised to power 2. So this over 1. So these two cancel these 2 here. So we have our M2 equals to when we raise 8.485 is our 2. We get 71.9. 71.9. So to all number we can get our M2 to be what? 80. So this is our final answer for number 2. This is our final answer for number 2. If you are confused there, just say that okay, maybe you are not familiar with this kind of method. The same thing, just come here, square both sides, come here, square both sides. So you can see these 2 cancel this what? This square root here. These 2 cancel this square root here. So this one is so this square root is off. So then this one is our 2. You get this and this. So this is our 72 rather 72. So this is our final answer for number 2. Now I will make the video to be part 3, so which is a continuation on the calculation under Graham's law of diffusion. Please do well to hit the like button. As you hit the like button, this video is also being pushed by YouTube in order to be of help to other students as well, because we don't want other students to be struggling when it comes to field like this. We want them to be helped also. So you can help the other students by hitting the like button and sharing it to and by sharing it to them also. So till next day, I pray that the grace of our Lord Jesus Christ be with every one of us and everything that pertains to us. Thank you very much.